A big attraction of the PBMR was the underlying technology. Now, at the time of the PBMR's conceptualization, most of the world's nuclear reactors were what were called pressurized water reactors. Pressurized water reactors. The PBMR was a high-temperature gas-cooled reactor. So a high-temperature gas-cooled reactor, like the PBMR, differed from the world's existing nuclear fleet of pressurized water reactors. The first major difference was that the PBMR had an output of between 110 and 400 megawatts. Now, a typical pressurized water reactor that had been commissioned had a corresponding output of 900 megawatts to 1,200 megawatts. Secondly, the primary coolant in the PBMR was helium gas as opposed to water for the pressurized water reactors. And thirdly, with the PBMR, the coolant, or specifically the helium gas, drives the turbine to generate electricity directly. It does it directly. In contrast, with pressurized water reactors, the coolant is funneled through a heat exchanger that subsequently generates steam and only then propels a steam turbine. Fourth, the PBMR utilized graphite as the moderator rather than water. And fifth, while the PBMR could be refueled whilst it was still operating, pressurized water reactors had to be shut annually for refueling. So lastly, the PBMR utilized uranium enriched to 7.5%. Conventional PWR reactors utilized 3% enriched uranium. Now, these technological differences are important to note because at face value, they endowed the PBMR with a number of significant advantages over the existing pressurized water reactors. And we're going to go into the detail in terms of what those advantages are.